Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about the Fundamental Theorem of Calculus.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, the integral of -5 to 1 of a negative absolute value of x squared plus 4x dx, and we have to evaluate this definite integral. Now this is a tricky one, and I first see this absolute value, and we need to figure out what x values we need to plug in, how can we rewrite this, okay, without the absolute value, but still have the rules of the absolute value apply. So I'm going to take what's inside of the absolute value, x squared plus 4x, and I'm going to see where it's equal to 0. To plot an x, we have x times an x plus 4 equals 0. X equals 0, so each part equal to 0, x plus 4 equals 0, and x equals a -4. So we have 0 and -4 are my two main values here, okay? So we're going to rewrite this to be without the absolute values, but we're going to have to do a little trick. So first we have our lowest value, so -5 to -4. So the integral from -5 to -4 of a negative, and then we have what's inside, the x squared plus 4x right here, dx. But I want to see if I need to cancel this out to see if I need to put a negative outside to cancel out this x squared plus 4x right there. Well, between -5 and -4, what happens on the inside? Well, if we plug in, let's say, a -4.5, -4.5 squared is a positive number that's going to be greater than 4 times a -4.5. That's between these two values here. And so therefore, it's going to be positive on our range from -5 to -4. So we're good, so we don't actually need to change anything here. Add integral, next area is -4 to 0. Same thing applies. Between -4 and 0, what happens? Let's plug in a -1, let's say. -1 squared is a positive number, but 4 times -1 is a negative. We have a negative inside of this absolute value. So what we're going to do is, we have the negative, it's already up there, we need to put a second negative, and then we still have the x squared plus 4x dx. And hopefully you can see negative makes it a positive. Lastly, when you add again, we're going from last one, 0 to a +1 here. 0 to 1 of our function here. And between 0 and 1, let's put a 1/2. All numbers are positive. It's going to be a positive inside of the absolute value here. Don't need to change anything. Minus a x squared plus 4x dx. Okay. Well, let's go evaluate each one of these integrals here. Okay. Well, to do that, we have the integral, this negative sign, right, remember, gets distributed. The integral of x squared plus 4x with a negative, so negative x squared minus 4x is a negative x to the third power over 3 minus a 2x squared. And we're integrating this from a -5 to -4. Plus, same thing here, integral of x squared plus 4x is an x to the third power over 3 plus a 2x squared, integrating this from -4 to 0. Plus, same as before here, we have is a negative x to the third over 3 minus a 2x squared, and we're doing this from 0 to 1. Okay, a lot of work here, so keep everything lined up. We're going to rewrite this now. We're going to plug in our f of b and f of a for each one here. Okay, so we're going to plug -4 in for x. So let's put a little bracket here around what we're doing. -4 in for x. So -4 to the third power over 3 minus 2 times the -4 squared. Minus, same thing, we plug -5 in. -5 to the third over 3 minus 2 times the -5 squared. Plus, all right, we're going to deal with the second one right here. Okay, that's going to be right here. Got to write smaller here. So plug 0 in first. 0 to the third power over 3 plus 2 times 0 squared. Minus, plug in -4 into my function here, the second one. -4 to the third over 3 plus 2 times -4 squared. Plus, we're on the last one, hopefully I have enough room. Put 1 in for x, so we have -1 to the third power over 3 minus 2 times 1 squared, minus put 0 in. Luckily it just goes to 0, but I'll show the work. 0 to the third, negative 0 to the third, over 3 minus 2 times 0 squared. And that should just be in. All right. So, all that lovely work here, let's go simplify, and I've done the work for you. This whole part right here, when we plug negative 4 into the first integral, we have a negative 32 over 3. Minus, we plug negative 5 in, right here, the second part, negative 5 goes in right here, that's a minus 25 over 3. Plus, when 0 goes into the second integral, we have a 0. When a negative 4 goes into the second integral, we have a 32 over 3, and we're subtracting that. Okay? Plus, on the last integral now, we plug in a 1 into the last integral, we have a negative 7/3. Minus, we plug 0 into the last integral, we get a 0. So, all that comes out to be right here. Negative 32 over 3 minus a negative or plus a positive 25 over 3 plus 0 minus 32 over 3 plus a negative 7/3 minus 0 comes out to be, I did all the good work for you, negative 46 over 3, which is equal to a negative 15.3 repeating. So after all of that, splitting it into 3 different definite integrals to solve, our integral from negative 5 to 1 of our function with the absolute value is a negative 46 over 3. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math, when you need help you use Minute Math.